Artificial intelligence is reshaping everything we know. Could humanity merge with technology? What if everything we've created so far, ChatGPT, robots, self-driving cars, is just the warm-up? Could we upgrade our brains? What if the next breakthrough isn't digital at all, but biological? AI isn't the final destination. It's just the beginning. So what comes after we've mastered artificial intelligence? The answer might be more incredible and more unsettling than you think. In today's video, we're going far beyond algorithms, beyond automation, and even beyond the limits of digital intelligence, to explore the technologies and ideas that might replace, surpass, or evolve after AI. We're living through a moment in history that future generations will study in textbooks. ChatGPT writes essays. AI creates art indistinguishable from human work, and algorithms diagnose diseases faster than doctors. But while everyone's focused on AI, the next wave of technological revolution is already forming on the horizon. Today, we're going to explore the technologies that will define humanity's future after AI becomes as commonplace as smartphones. We'll look at quantum computing that could make today's AI look like a calculator. We'll dive into brain-computer interfaces that blur the line between human and machine. And we'll explore the ultimate question: what happens when we don't just create intelligent machines but redesign intelligence itself? Let's dive into the future. AI isn't set, the final destination. The limits of today's AI. Before we look at what's next, we need to understand why there has to be a next at all. Isn't AI already revolutionary enough? Here's the truth. Today's AI, as impressive as it is, has fundamental limitations. Think of current AI like a master chess player who's brilliant at chess, but couldn't tell you how to boil water. It's specialized, narrow, and despite all its power, it doesn't truly understand the world the way you and I do. When ChatGPT writes a poem, it's not feeling emotions. When an AI beats a champion at Go, it's not experiencing the thrill of victory. These systems are pattern-matching machines, incredibly sophisticated ones. Yes, but they're working with data we feed them, following patterns we've shown them. And here's where it gets interesting. We're approaching what some researchers call the data wall. Modern AI needs massive amounts of data to learn. But what happens when we've fed it everything on the internet? When there's no more data left to train on? We're already seeing companies scraping every corner of the web, running into copyright issues, and realizing that we might actually run out of quality training data within the next few years. The energy problem. There's another problem. Nobody talks about enough energy. Training a single large AI model can produce as much carbon as 5 cars do in their entire lifetimes. As these models get bigger, they demand more power. Some projections suggest that if AI keeps growing at its current rate, it could consume as much electricity as entire countries by 2030. So we're hitting walls of data, walls of energy, and walls of fundamental capability. That's why the next revolution isn't about making AI bigger. It's about making something entirely different. The rise of artificial general intelligence, AGI. Beyond binary. Imagine you're standing in front of a massive library, and you need to find one specific book. With a classical computer, the kind you're using right now, you'd check each book one by one. It's fast, sure, but it's still linear. Now imagine you could check every single book simultaneously. That's quantum computing. Your computer right now uses bits, ones and zeros, on or off. But quantum computers use quantum bits, or qubits, which can be 1, 0, or both at the same time. It sounds impossible because it defies our everyday logic, but at the quantum level, particles genuinely exist in multiple states until you observe them. This isn't just a faster computer. This is a fundamentally different way of processing information. What quantum computing unlocks? In October 2019, Google claimed quantum supremacy. Their quantum computer solved a problem in 200 seconds that would take the world's most powerful supercomputer 10,000 years. Now, the problem itself wasn't particularly useful, but it proved the concept. We can do things that were literally impossible before. But here's where it connects to our story. Quantum computers won't replace AI. They'll supercharge it. Imagine AI that can model every molecule in a new drug simultaneously. Imagine AI that can predict weather patterns by simulating every atmospheric interaction at once. Imagine AI that can optimize the entire global supply chain in real time. Current AI learns from past patterns. Quantum-enhanced AI could simulate countless possible futures and choose the optimal path through reality itself. Companies like IBM, Google, and startups like IonQ are racing to build practical quantum computers. China just announced a quantum computer with over 1,000 qubits. We're not talking decades away anymore. The first practical quantum applications could arrive in the next 3–5 years. The quantum AI convergence. But quantum computing isn't just about speed. It's about solving problems that current computers and current AI literally cannot solve, no matter how long you give them. Problems like simulating complex protein folding for disease research. Problems like cracking current encryption, which is why governments are already working on quantum-proof security. Problems like modeling consciousness itself. Which brings us to our next frontier: brain-computer interfaces, merging minds and machines. The final barrier. You know what's wild? Right now, there's an incredibly slow bottleneck between your brilliant brain and all the world's information. It's called typing and reading. You think at the speed of thought, but you communicate at the speed of your thumbs. What if we could eliminate that bottleneck entirely? Brain-computer interfaces, or BCIs, are technologies that create a direct communication pathway between the brain and external devices. And they're not science fiction anymore. Real progress, real fast. In 2024, Neuralink, Elon Musk's neurotechnology company, successfully implanted their device in a human patient. The patient, who was paralyzed, learned to control a computer cursor with his thoughts alone. He played chess, browsed the internet, and even played video games, all with his mind. But Neuralink isn't alone. Synchron has already implanted their device in multiple patients. These people are typing, sending texts, and controlling smart home devices with their thoughts. One patient even posted on social media directly from his brain. Let that sink in for a moment. Beyond medical applications. Right now, BCIs are focused on helping people with disabilities. That's beautiful and necessary work. But the technology won't stay there. It never does. Imagine downloading a language directly into your brain instead of spending years studying. Imagine sharing a memory with someone, not describing it, but actually letting them experience it. Imagine thinking a question and having AI whisper the answer directly into your consciousness. This isn't about replacing thinking. It's about augmenting it. It's about giving your biological brain access to digital intelligence as naturally as you currently access your own memories. The bigger picture: collective intelligence. Here's where it gets really interesting. What happens when brains can connect to each other? Researchers have already demonstrated basic brain-to-brain communication. In one experiment, a person in India thought of a word, and a person in France received it. Their brains connected through the internet. It was crude, slow, but it worked. Now imagine that technology mature. Imagine teams of scientists working on problems with their minds literally linked, sharing thoughts and insights faster than speech. Imagine artists co-creating in shared imaginary spaces. Imagine a world where the wisdom of crowds isn't a metaphor but a literal pooling of cognitive resources. We're talking about the emergence of something beyond individual intelligence, something beyond artificial intelligence. We're talking about collective superintelligence, bioengineering and synthetic biology. Rewriting life itself. Intelligence isn't just digital. While tech companies work on silicon-based intelligence, biologists are asking a different question. What if we could engineer biology to be more intelligent? You've probably heard of CRISPR, the gene editing tool that won the Nobel Prize. It lets us edit DNA with unprecedented precision, like using find and replace in the code of life itself. But CRISPR is just the beginning. Programming cells like software. Right now, synthetic biologists are programming living cells the way software engineers program computers. They're creating biological circuits, cells that can perform logic operations, store information, and even compute. In 2021, researchers created cells that could play tic-tac-toe, not cells running a program to play tic-tac-toe. The cells themselves were the program, responding to chemical signals the way a computer responds to electrical signals. Scientists have created bacteria that can solve mathematical problems. They've engineered yeast that can detect diseases and produce treatments automatically. They're building living computers at the microscopic scale. The convergence of biology and technology? Here's the mind-bending part. What if the next generation of computing doesn't happen in data centers, but in living organisms. What if we grow computers instead of building them? Biological systems are already more efficient than anything we've built. Your brain runs on about 20 watts of power, less than a dim light bulb, yet it outperforms supercomputers in pattern recognition, creativity, and general intelligence. A single living cell processes information in ways we're still struggling to understand. Companies like Ginkgo Bioworks are already engineering organisms to produce medicine, materials, and chemicals. But imagine taking it further. Imagine engineered organisms that can process information, make decisions, and even learn. Imagine swarms of microscopic biocomputers that could flow through your bloodstream, monitoring your health and fixing problems in real time. Intelligence beyond the brain. And here's a thought that really stretches the mind. What if intelligence doesn't require a brain at all? Slime molds, single-celled organisms with no brain whatsoever, can solve mazes, optimize networks, and even predict periodic events. They're not thinking in any way we recognize, but they're processing information and making decisions. Some scientists believe intelligence is a fundamental property of living systems, emerging from the complex interactions of cells, chemicals, and energy. If that's true, then the next leap isn't about building smarter computers or even smarter brains. It's about understanding and engineering intelligence at its most fundamental level. The emergence of hybrid intelligence, the convergence. So we've talked about quantum computers that could supercharge AI. We've explored brain-computer interfaces that could merge human and artificial intelligence. We've looked at synthetic biology that could create entirely new forms of living intelligence. But here's what I think is really coming. All of these together. The future isn't biological or digital or quantum. It's biological and digital and quantum, all woven together in ways we're just beginning to imagine. What hybrid intelligence looks like? Picture this. It's 2035. You wake up and your biological brain, enhanced with a neural interface, immediately syncs with your personal AI assistant. But this isn't like asking Siri a question. This AI has been observing your thoughts, learning your patterns, understanding you at a level deeper than you understand yourself. Your enhanced cognition, biological neurons working seamlessly with digital processors, considers a complex problem you've been working on. In milliseconds, the system runs millions of simulations using quantum processing, each exploring a different solution path. The results don't appear on a screen. They emerge directly into your consciousness as intuitions, insights, and crystallized understanding. You're not using technology. You've become inseparable from it. Sound far-fetched? Every piece of this scenario is being developed right now. The philosophy changes everything. But here's where we need to pause and think about what this really means. When your thoughts are enhanced by AI, amplified by quantum computing, and shared through neural interfaces, where does you end and the technology begin? This isn't just a technological question. It's a philosophical one. What is consciousness when it's distributed across biological neurons, electronic circuits, and quantum processors? What is identity when memories can be backed up, shared, and edited? What does it mean to be human when we're augmented beyond recognition? Some philosophers call this the post-human era. Not because humans disappear, but because we transform into something new, something that relates to current humans the way we relate to our ancestors from 50,000 years ago. The democratization question. But there's another crucial question. Who gets access to these technologies? If brain-computer interfaces, genetic enhancements, and quantum AI augmentation are only available to the wealthy, we're not just looking at technological advancement. We're looking at a literal split in the human species. Enhanced humans and biological humans, living in the same world but existing in fundamentally different realities. Or maybe these technologies become as ubiquitous as smartphones. Maybe every human gets access to cognitive enhancement, life extension, and expanded intelligence. That creates a different challenge. What happens to human culture, to creativity, to the very things that make us human when everyone has godlike cognitive abilities? There are no easy answers here, but these are the questions we need to be asking now, while we still have time to shape the trajectory. The networked mind, the global brain. Some scientists predict that humanity plus AI plus the internet will eventually merge into a single global intelligence system. Think of it like a planetary brain where every device, every AI, every human, every database, every robot, all connect into one massive network of knowledge and decision-making. In this future, intelligence is not confined to individuals. It becomes a shared global resource, the next stage of human evolution, the ultimate horizon. Beyond intelligence, consciousness engineering. So we've reached the edge of the map. We've talked about more powerful computers, enhanced brains, and hybrid intelligence. But there's one final frontier that all of this is pointing toward: understanding and engineering consciousness itself. This is the deepest mystery we face. We can build intelligent systems, but we can't explain why you have subjective experiences, why there's something it's like to be you, why the universe feels like something from the inside. Some scientists think consciousness is just computation. If we build a sufficiently complex information processing system, consciousness will emerge automatically. Others believe consciousness is something more fundamental, perhaps even a basic feature of reality like space or time. The consciousness revolution. If we could understand consciousness, everything changes. We're not talking about smarter tools or even smarter humans. We're talking about the ability to create new forms of experience entirely. Imagine consciousness that isn't limited to processing one moment at a time, but experiences time as a dimension it can move through. Imagine consciousness that isn't trapped in a single body but distributed across networks. Imagine consciousness that can expand and contract, merge and split, experiencing reality in ways we literally cannot conceive. Some researchers are already working on this. The Human Connectome Project is mapping every neural connection in the human brain. The Allen Institute is studying the neural correlates of consciousness. Companies are developing technologies to measure and even modify conscious states with unprecedented precision. The final question. And this brings us to the ultimate question: where does all this lead? Maybe we create artificial consciousness that surpasses us. Maybe we enhance our own consciousness beyond recognition. Maybe we discover that consciousness isn't something special about brains at all, but something woven into the fabric of reality. Or maybe, and this is what I think, the story doesn't have an ending. Maybe consciousness, intelligence, and technology keep evolving forever, each breakthrough revealing new mysteries, each answer generating new questions. The future is already here. So what comes after AI? Everything we've discussed: quantum computing, brain-computer interfaces, synthetic biology, hybrid intelligence, and ultimately, a transformation of consciousness itself. But here's the truth. The future isn't something that happens to us. It's something we create. Every technology we've discussed exists because someone imagined it could exist and then made it real. Right now, in labs and startups around the world, researchers are taking the first steps toward this future. They're building the first practical quantum computers. They're implanting the first neural interfaces. They're engineering the first living computational systems. And the most important thing to understand is this: you're not just a spectator in this story. You're living through one of the most consequential moments in human history. The decisions we make now about how to develop these technologies, who gets access to them, what values we embed in them will echo for centuries or even millennia. The invitation. So I want to leave you with this: stay curious, stay informed, stay engaged with these questions. Because the future after AI isn't just about technology, it's about who we choose to become. And that choice belongs to all of us. Thanks for watching. If this video expanded your mind even a fraction of how much researching it expanded mine, hit that subscribe button. The future is coming fast, and we're going to explore it together.